Okay, this was started up at about 10 o'clock this morning. It's currently 12:27. She's been fully running. All right, what we're going to do is take it down and bring it back up and demonstrate the process of how we're clearing this. That's the load over there at 60,000 volts at 40 mils, and the small top resistor is our filament. It's loading to about 60 watts for the filament. So, all right. Let's see, safely take this thing down. I need to reduce my current setting, my voltage setting. My high voltage is falling off. And once the high voltage drops down, I'll go ahead and turn the power off. Up there. And okay. All right. So back. Okay. So basically, to start this puppy up, we want to make sure our filaments has been selected for the transformer in the tank. Set up filament 1 right now. We're gonna first thing we're gonna monitor is the filament voltage and make sure that comes up in standby. This particular unit will bring up the filament. This particular unit starts up with filaments in standby. Your other unit does not. They're programmed to run differently, and we'll demonstrate that on the next one when I show the burn-in. So, anyway, we've got a voltage applied to our filament selection switch. We've turned it on. First thing we do, make sure that we've got 12 here for our auxiliaries. We've got 2 controls. 6 volts will equal 60,000 volts. 4 volts here will equal 40 mils. First thing we're going to do is monitor the filaments, make sure it comes up when it comes up, and I should be at 0 high voltage. So everything's applied except just throwing the breakers. We'll go ahead and turn the breakers on. All right, here we go. We've got filaments now at 2.3. This is a standby filaments. Allows them to warm up on this one without the high voltage being up. Like I said, the other one's different. The high voltage has to be up to about 15,000 before the filaments will come up. So it's by circuit design. Even though they're the same number, there's 2 different versions of circuits. So this one, by the way, is the one that was in your inventory as a spare, and we sent back fully repaired last time to you. And you said you installed this one to replace the original one that faulted, which is over there. So anyway, that's what this one is right now. We'll show you the other one here in a bit. So, to bring this up, we'll go ahead and turn on our current control and turn on our high voltage control. Over there, my high voltage will start to come up as I increase the power. There we go. So now that I'm increasing power, that's only about, what, 4,000, 5,000. I'm going to go over and check my current monitor and make sure that I'm reasonable. That's great. I'm going to go ahead and make sure my high voltage monitor is agreeing with my high voltage meter. There's my high voltage monitor at 263. 265 is the actual reading. That's well within tolerance. I mean 465 and 463. All right, so I'm going to go ahead and bring this up to 60,000. Slowly increase this. We're not going to do it real hard. So there's 10,000, we're going to go to 15, it's 20,000 volts. I'm going to go ahead and take it all the way up to 60. I'm going to go slowly. I don't want to overshoot it on this one. It's currently being loaded through 1.5 million ohm resistors. That's most of the resistors on the bottom side of that stack. About 68 of them to be exact. All right, we're coming up to 50,000. We're going to start really pulling some AC current now. We're going to get up to about 9 or 9.5 amps AC, putting in this thing at 200 volts. There's 57,000. Okay, coming up close to our maximum. There's our maximum. There's 60,000, and my current at 60,000 into 1.5 million ohms over there should be 40 milliamps. And if I check this, I'm running 40 milliamps right now, so I am 100% loaded on the high voltage completely. Now, in order to get the filaments to come up, the program voltage for the filament has to exceed what the actual filament's reading is. This is a broken closed loop control system, so this is normally closed loop with the filaments heating up. That's how they control the amount of current, okay? We don't have the luxury of that with the machine in here, so what we're going to see is kind of a very discrete hysteresis between the filaments being on and the filaments being off, because we're open loop right now. So what I'm going to do is I'm going to back the high voltage down just a little bit, so I'm just a little bit under 40 milliamps of current. I'll take this back down to maybe about 56 or 58 or something. You let that settle for a second. Okay, so it's going to settle at about 56,000 volts, and my current reading right now is 37.2 milliamps. I'm going to move over to monitor my filaments, which should be 0 at this time, and then I'm going to command the drive circuit so that it tries to make the current I'm looking for, which was, what did I say, it was 3.7? 3.7. Okay, so roughly at about 3.7 volts here, which means I'm going to command it to give me the current necessary to run at 37 milliamps. We should see that switch and turn on the filaments. Again, if this was closed loop, it would actually regulate, but there's no regulation here because we're open loop. I'm going to increase this. When this gets up to about 3.7, I should see it change over. So we're sneaking up on it right now. 3.5, 3.7, there you go. So at 3.7, I've now asked it to do that. So in other words, if I increase this all the way up to 40, it's asking for 40 milliamps of current. And the way it would normally do it if it was closed loop is the heater would heat up in your X-ray tube. The high voltage current would increase because the effective resistance starts to drop as we get more emissions. Keep in mind, I have a static load, so I don't have the ability to change the current setting. That's why we're open loop. All right, so there we go. The top resistor over there is the small resistor. Yeah, the small resistor on the top of that lower stack is our filaments. Currently running at 2 ohms. I'm running roughly about 65 watts. We've done the math, and this circuit is right here is where our filament control or filament output switchers are, and there's a pretty good chunk of heat in there. This has got to be pretty close to where the X-ray tube actually runs. We don't know for sure where it is, but we've done the math on it, and that's about all this is actually going to supply. It might go up to about 100 watts, but I don't want to risk blowing it because there is no thermal protection for that circuit, and there's no overcurrent protection for that circuit. The only protection is it's going to blow a fuse, and it's going to do that when the FETs let go, so we're not going to push it that hard. Again, so this is the way it's running, and there, and I've let this thing run in this condition for, 4 hours now, and without any trouble whatsoever. Again, I can check the hysteresis of the control loop. I'll bring the control loop below 3.7. As soon as I do, the voltage to the filaments drops clean off. You should see that that point of changeover is very, very close to the actual current. 37.2 milliamps. I'm asking for 36 point, God knows what. That meter's not particularly accurate. As I increase it up, I'm sorry, I got to go over and monitor the filaments. I see the filaments are already on. So you see where I get my switch point for getting the filaments to turn on and off. Right there, they're off at 3.6 on this meter. And right there, they turned on 3.7. So everything's tracking at the voltage and set points that it's supposed to. And everything has run with full temperature and been burned in. I mean, I don't have the capability of running this thing for 2 weeks like this, but everything I can prove on it that should work is working. So I'm going to go ahead and take this one back down and go ahead and hook up the other one. We'll let the other one, we'll get it checked out, number one. I don't know about the other one yet. It hasn't been hooked up yet. If it has problems, I'll report to you on that. Otherwise, as soon as I get it hooked up, fired up, if it runs, I'm going to give you the same demonstration on it. So you have proof both these two have been fully loaded. Thanks a lot. See you later, Aaron.